Okay, so for the first problem, I'm looking at this function and I'm thinking, oh man, this 2 is messing everything up. If he would just get rid of the 2, then I could do the problem. The answer would be 1. Well, just get rid of the 2. So write this as 1/2 limit as x goes to 0 of sine x over x. And so I get 1/2 times 1, which is just 1/2. So there is the first problem done. But now I'm going to mix it up a little bit on you, and I'm going to put the 2 inside the sign. Just, I guess, because I'm mean, I don't know. I'm curious, what happens if we put the 2 inside the sign? And so here's the trick. This is the main trick that you'll need for the homework, and that is simply this. So we learned that the limit as, I'm going to write theta goes to 0 of sine theta over theta is 1. And the point is, I want you to think about the theta as like a box. Okay, so sine box over box as box goes to 0. As long as whatever is here is exactly there, these are the same, and whatever is here that's also there is going to 0, you're always going to get out a 1. And so the point is this. I'm going to erase all of that. The point is you really, really, really need to get a 2 there. Because if you could get a 2 there, x going to 0 means 2x is also going to 0, and you'd be done. This would just be 1. How do you get a 2 there? Well, just make one appear. Let me show you how to do it. So sometimes you just need to write down what you want, and maybe it'll happen. So sine of 2x, I'm just going to put the 2 there, but I have to get rid of that 2, so I'm going to put a 2 upstairs to cancel, right? So I haven't changed the problem because these 2's cancel, and yet the way that I've got it now, this limit goes to 1, and so this is just, you can pull the 2 out if you want. 2 limit, I'm going to write out the extra step here. I guess you probably don't have to do this, but I would write it like that, and this is exactly 2 times 1, which is 2. All right, 2 more of these. So this one, I flip things around on you. Oh my. Well, for this problem, you think, man, if he would just flip it, I'd be good to go. Fine. If that's the case, then flip it. You can write this as 1 over sine x over x. Do you agree? Because if you flip this back up, you get this. So I haven't changed anything. This is exactly the same problem from here to here, and yet I know what this one does. The bottom goes to 1. We're using the limit laws here. We have a fraction of 2 pieces. Top goes to 1, bottom goes to 1. So this is exactly 1 over 1, which is just 1. All right, very last problem. Here we go. This is it, and the video is over. This was a long series. Oh boy, tricky. Sine of 2x over sine of 3x. There are different ways of doing this, but here's how I'm going to do it. I'm going to write this as the limit as x goes to 0 of the sine of 2x over x times x over the sine of 3x. Now, some of you are wondering, what is he doing? Well, put it back together. When you do this part over that part, the x's cancel, and you're right back here. I'm just spreading it out in a way that lets me use limits that I know already. And now I really want a 2 there, so I'm going to put 1 there. You know what? I'm going to, just for your note's sake, I'm going to copy this and then and do it again down here because I don't want you to get confused. Okay. So let's do that. All right, I want a 2 there, so I'm going to put a 2 there and a 2 here. I want a 3 there, so I got to put a 3 down there. And now you can see this part goes to 1, this part goes to 1. And so you're left with, let's actually write it as this. You're going to pull this 2 is coming out, and then this 3 is coming out. So I'm going to get 2/3, limit as x goes to 0 of sine of 2x over 2x times 3x over the sine of 3x. Both of those go to 1, and so this is exactly 2/3 times 1, which is 2/3. All right, good job. You did it. That's 1.4, and we'll see you next time.